So, mm, what? So we can start, right?
Yeah.
Mhm. So basically, we will today uh, in this particular class we will discuss only about this mutable versus immutable infrastructure. So what does it do, and what are the how why is it important to have a in terms of Kubernetes architecture? So uh, yeah. So basically, mutable infrastructure. So basically this is a traditional infrastructure. So you deploy the software and then you incrementally update it over time. So
Mhm.
using the commands like
Mhm.
apt apt-get or yum install depending on your flavor of Unix, Linux box. And then you update some like some old binaries. Update with the newer ones, and then we change some config files and with the newer one. So this is all like old school, like traditional process of deploying the software. So the key point to note here is like
Mhm.
we are replacing the replacement of the old code and its dependent software with new code every time whenever we upgrade. Okay, so this is the old style. Now, immutable infrastructure. When we say
Okay.
immutable infrastructure, so this is mostly found in the container-centric environments. So basically, we build a new Docker image, and so then
Mhm.
we this. But the key point here to note here is basically we can run both the old containers and the new containers simultaneously. Suppose we are doing a upgrade, like suppose there is a banking application, uh, say ICICI.com upgrade is happening. So if we are seeing
Mhm.
a message like website is down, that means they are using a mutable infrastructure. But if they are using an immutable infrastructure, that means
Okay.
you can basically run the old container, that is the old application, and the new application simultaneously. I mean, the upgrade is happening simultaneously, and the application is never down.
Mhm.
So basically, that is called as in Kubernetes we call it as a rolling update, and and this can be done with a minimal of downtime. So the concept here is basically, I mean, the key difference is like we are not updating the software in the running container. So basically, you have a container, we are not updating it. You also have the previous container and you also have the new container. So this enables the fast rollbacks. In case there are some software
Mhm.
rollout errors or something like that, we can simply kill that new container and then we can start. But the old container is still on. I mean, it's not that we are doing any upgrades in the old container. So basically the concept is uh, whenever there is a data change, don't overwrite the data, existing data. Just create a
Mhm.
new record. Basically, just create a new record
Okay.
always. So that is a
Mhm.
similar concept is being used in the
Okay. Okay.
immutable.
Okay.
Yeah. So that is called the immutable container images. So
Mhm.
basically, this is the core concept of the whichever of the apps which are deployed using Kubernetes. So we should note this thing. It's a key point for interview as well. Okay.
Okay.
So YAML refresher. So
Okay.
we already discussed about YAML, but this today we will go a little bit deeper into
Mhm.
what what does a YAML looks like. I mean, it looks like, I mean, it's not a big thing to understand, but we should understand the bits and pieces of it actually. So basically, the pod YAML, the name is like
Okay.
YAML Ant markup language. I mean, it's why I don't know, but it's called like that, like YAML Ant markup language.
Okay.
And if you see in this file, so basically
Okay.
here in this file we have like these all these key value pairs like the API version v1, kind, pod, metadata, name, all these are key value pairs. Okay, so
Mhm.
so
Mhm.
like a name nginx, image nginx, volume mounts. Then, but if you see here,
Mhm.
I mean they are all written in a particular fashion. Like they are all there's a spacing in between. So basically, YAML uses an indentation based scoping. So basically, we have to define the
Mm-hmm.
structure
Okay.
of this in a very peculiar fashion, like very much similar to like Python. In Python also we need to be very much careful about the indentation. So the similar thing is with YAML as well. Um, so indentation is defined as a zero or
Mm-hmm.
like or more white space characters. I mean, we just like these are not very important things to understand, but just to let you know that okay, that this is a very like sensitive in terms of indentation. So if the spacing is not done correctly, so the YAML will not be correct. YAML file will be invalid actually. So and you can
Okay.
also, if for illustration purposes, you can have a you can write a comments here, like if suppose this nginx container basically a docker image, so you can
Mm-hmm.
write in hash and like then like write it like what in short sentence, like for any other developer to understand what does this container has in between inside it.
Okay. 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 Okay.
So just put a hash sign and just you
Okay.
write some comment like that, a very basic thing, so not a big deal. So the other thing is like we should the so basically this is called like the way it has been written is called like data serialization standard, and that is this is the reason it is extremely readable.
Mm-hmm.
And so like that is one thing to note here. And the abbreviations are like YAML, we talked about like YAML and markup language. And the other thing is like
Mm-hmm.
basically mapping of mappings. So this is another key thing here. Like
Okay.
if you see here, this is a simple thing, API version and v1. This is a one key value pair, one key and one value. But if you
Right.
see metadata,
Yeah. Yeah. Yeah.
metadata has a mapping of mappings. It has a name,
Mm-hmm.
it has a spec, and then it has a containers. So basically, if you see here, metadata
Mm-hmm.
has like this list of
Uh-huh.
values, it has one key but so many values.
Mm-hmm.
So like by map, but then that value
Okay.
itself is a key for another value. So if you see here, like these are like mapping of mappings. So basically the um, these key containers,
Mm-hmm.
so this basically
Okay.
maps to a sequence of mappings.
Okay.
So each like this dash and a space is used to is to indicate the, so basically it means like there are two images here, like one is like a nginx image and another is a git monitor image. So these two symbols denotes that. But
Okay. Okay.
they are themselves
Okay.
like like nested, they are like nested key value pairs, but they are a part of the parent container,
Okay.
which container is also a value for a spec. And spec itself is also a value for a, I mean, that is a key, spec is a key for container, but that spec itself is a value for name. Yeah. So
Okay.
that is called like a mapping of mappings here. So basically you can you can have like a nested architecture. And I mean, we don't have to build like this, but I mean, I'm just saying like this is the way that data serialization happens. And uh, so
Mm-hmm.
like basically colon and a space, this colon and a space is basically we define that there is a mapping in YAML, and mapping is like a key value pair. So if you wherever you see a colon,
As a format or something.
yeah, that is a format. So whenever you see a colon and a space, so that is a key value pair. Again, you see here colon and a space,
Mm-hmm.
that is a key value pair.
Okay. Okay.
So
Okay.
these are all like key value pairs. So,
Mm-hmm.
but they,
Okay.
and, what we can see like if you see here, um, yeah. So the key if you just see these containers like this is a key which but it maps to a sequence of mappings
Mm-hmm.
like if you see here, this is one sequence, like one dash is there and another dash is there. And
Okay.
so basically this container has
Okay.
two mappings, like one is this and two is this. One is nginx, one is git monitor. And
Okay.
for metadata we have two, like one is
Mm-hmm.
name and one is volumes. If you see at the bottom,
So what
uh,
is metadata?
metadata is like a this is also a key. That is also a key. So but it has values. Like it
Mm-hmm.
has two values. Like one is name and
Mm-hmm.
another is volumes. Okay, but then name itself
Okay.
again it's a mapping of some. It's like a nested architecture. I mean, it's like a
Mm-hmm.
mapping of mappings, so like that. So if you see here, like this spec has containers. So containers,
Okay.
but this container is a value of spec. But this container is also a key for these guys, like name these two Docker images, like Nginx and Git monitor. So the beauty of this is you can you can have one application.
Mm-hmm.
You can have multiple applications running within the one same YAML file. So basically, this is the example of two applications. One is like Git monitor. This is this image called Kubernetes slash Git
Mm-hmm.
monitor, and this another image. This is a public image.
Okay.
So like Nginx and this volume mount. So basically, in this application, in this Nginx Docker image, they have mounted this volume like slash srv slash this is the path. So suppose there is a output. Suppose the application is generating some
Okay.
output. So you can have that output mapped with this Linux. So basically, these are all works on Linux machines.
Mm-hmm.
So Linux machine is the agent. So basically, this is the host. That is the host, Linux, and this is the application.
Okay.
So you can map these volumes with the local like local OS. So local OS is Linux, but
Path.
the container image is Nginx, and we have one more Git monitor. So
Okay.
we are mounting these volumes
Mm-hmm.
with uh, the local, but the volumes are. I mean, there are. It's not that only you can map with the l- local local OS. You can also have like this
Mm-hmm.
for example, like these volumes. These volumes. This is the name. This is just a name of this volume, and empty dir. As the name suggests,
Okay.
this is a empty directory,
Mm-hmm.
but this is like a local caching directory. And this is not a local. I mean, this is not like it doesn't depend on your host OS. It will just hold the value till the time this container is active.
Okay.
That like this Nginx container is active, and this Git monitor this
Okay.
whenever till the time these two containers are active, the data like will be cached here
Mm-hmm. Okay.
for a momentarily, like
Okay.
for a moment of time. The data will be cached in this empty directory, and it depends on us. Like it depends on the
Mm-hmm.
developer what it wants to do. If he wants to simply copy the files to the local Linux machine, he can write a cp command, and then like kubectl cp. The kubectl is the way.
Mm-hmm.
Kubectl is the Okay, we'll talk later what is kubectl. Kubectl is the it's like a carrier like which talks between Kubernetes and the local machines and basically Linux machines.
Okay.
So yeah. So I mean, so
Okay.
this is just a basics of key things to understand. Like what are the key value pairs in YAML file? What are the like mm, various aspects of this YAML file, and what means what?
Okay.
So just
Okay.
just a thing to understand.
Mm-hmm.
So now we have understood. Now after looking at the YAML refresher, we'll understand like what is Kubernetes and Docker in which we are going to do in the next labs. So basically, as we keep on talking about Kubernetes
Mm-hmm.
manages the containerized applications. So we build our application and we push it to a Docker image. We create a Docker image. Now, when we build a Docker image,
Okay.
when we say we are pushing it to a registry, what does it mean?
Okay.
So this is the meaning of this is like
Mm-hmm.
basically a store. Container registries means a store wherein you suppose. as a developer, you just build your application. You code, you do a programming of your application, and then you build a Docker image and push it to these registries like Docker Hub. And other thing is like Google Container Registry, GCR. These are like the popular
Okay.
ones. So the QA,
Mm.
ECR is the
Okay.
Amazon's Elastic like container registry. ACR is the Azure's container
Okay.
registry, and Docker Hub is like
Okay.
Docker Hub is like a publicly hosted uh, registry. Anyone can access it. I mean, anyone can. You
Okay.
just push it. You just push it to the. You create a Docker image and push it to the commands are same for
Okay.
all.
Okay. Okay. Okay.
The
Okay.
commands are same for all these things, like all these clouds, all these container registries, but this is public. Docker Hub is public, and these are all like private. Docker Hub is like free to use. No, they will not charge. They do have a private registry as well, but that is not very much used. Mostly people uses companies
Mhm.
uses ECR and ACR and GCR. So when we say like I have built
Okay.
a
Okay. Okay. Okay.
so when we say like I have built a Docker image and pushed it, so this is the meaning of that. Like you create your Docker image, which contains the app, the application, and then we push it to either a Docker Hub or to a GCR or to ECR or to ACR. So these are the popular ones. So basically, these registries store and
Okay.
manage the distribution of container images. When we say manage and distribution, that means suppose your
Okay.
team, you have a private ECR in your company, and uh, so once you develop your code and you push it to the Docker this container registry, so other team members can use your image like
Mm.
here. And here we have mentioned right name nginx and name git monitor. So suppose you have built these are all hosted in the public cloud, Docker Hub, Nginx, Git monitor. So that is the reason we can simply write like this image, Kubernetes, the image name. So Kubernetes will pull this image
Okay.
directly. We don't have to provide any username,
Okay.
password like that because these are hosted on the Docker Hub. Docker Hub is a public registry. So anyone can just pull the image and run the application. So, but
Okay.
uh, ECR and ACR for that we need like authentication keys. So then only we can pull the we can like Kubernetes can pull this image and execute it. So that is a key difference. And so
Mm.
kubelet. So we talked about
Okay.
kubelet. Basically, when in Kubernetes, we you
Mm-hmm.
remember we in our previous sessions we talked about kubelet.
I
So
I remember Kubelet.
yeah,
Kubelet is something that we install on the each servers.
yes,
It's more like a
yes,
connector something.
yes. So
Mm-hmm.
kubelet pulls this Docker image from the container registry, and so basically kubelet
Okay.
pulls these from Docker image, Docker Hub or GCR, ACR, ACR, whatever. It pulls it. So kubelet is the guy.
Okay.
So basically it's a kubelet process which will pull this
Okay.
image. Now it's called default policy in Kubernetes is if not present. So basically what it means is um,
Mm-hmm.
suppose you have a Linux machine and AWS cloud, for example, you have AWS cloud and you have spun up some Linux machine, and in that Linux machine,
Mm-hmm.
you're trying to run the Kubernetes containers, Docker containers. So
Okay.
to do that, you need to have a kubelet installed in it. You need to have a like kubectl installed in it, and kubectl is nothing. It's like a shell program, but
Okay.
the default pull policy, like so, if not present,
Mm-hmm.
it means is suppose
Okay.
when you fire a command like kubectl run this image, run Docker image. So first of all, it will look into your Linux machine first that whether that Linux machine already has image, then it will not pull that image. Okay.
Okay.
But if you change it
Okay.
to if you change the default policy to always, like here, so whatever it so even if local Linux
Okay.
machine even if local Linux machine has a image, it will still override it. Okay, but if the pull policy,
Hmm.
if you mention it as if not present, then only it will pull. If it finds that okay there is an image,
Okay.
it will not pull the image, and it will execute whatever it has on the local machine, on the whatever it has in the present directory, it will simply
Okay.
execute it. Okay, it will not pull the image
Okay.
from the container
Okay.
registry. So
Hmm.
kubelet, basically when you write when you in your console you write some kubectl command. So kubectl calls this kubelet,
Okay.
and kubelet pulls the docker image. Okay, so uh, so that is the difference what I said about the pull policy. If you mention about if not present, or you can write like always. So if you mention always,
Okay. I'm not able to hear what you said. It was like breaking.
okay, okay,
It was
it was
breaking.
breaking.
I didn't.
Okay,
I'm not able.
yeah. So basically like basically with kubectl,
Yeah.
that's a like a bash program. That's a bash shell.
Mm-hmm.
Okay, so you have to write that kubectl,
Okay.
and then you
Mm-hmm.
write a command like pull image. Okay, so kubectl internally calls this kubelet.
Okay.
This is the internal kubelet process. This pulls the image from the registry, container registry. Okay, now you are with me?
Okay. Okay.
Yeah.
Okay.
So, but
Yeah. Yeah.
if your if the default policy, if suppose if not present, if it is mentioned like that, so it will look, first of all it will look in the
Mm-hmm.
local machine, in the local Linux machine, that whether you have that image or not. And if it is not present, then it will download that
Mm-hmm.
image into your local, into your local machine, into your local OS, basically Linux. Whenever we talk about OS, imagine we are always
Mm-hmm.
talking about Linux. Okay, because as remember, we talked about CNCF, like it was like a cloud.
Yeah.
Yeah, so basically Kubernetes always works on Linux machines only. So we you will not see anyone who
Mm-hmm.
is using a Windows machine on a for a Kubernetes project.
Okay.
So basically in Kubernetes,
Oh, okay.
yeah.
That is an interesting fact.
Yeah, yeah. So usually
Mm-hmm.
it's not like it will, I mean, because they go like Kubernetes and Docker, they go hand in hand. Like that is the way they have been built. And Linux machine and Kubernetes, they are like, so whenever we say like Kubernetes master nodes and worker nodes, so you have to understand that, okay, these nodes are all Linux machines. They are nothing else. They are not Windows machines. Okay. So,
Okay. Okay.
whenever we say like AWS cloud, we have spun up like 10 machines or 5 machines or 5 nodes. So those nodes are Linux machines, nothing else. Okay.
Okay.
Even with GitLab also. So whenever we say they were using GitLab
Okay.
runners, so those are all like Linux machines. So
Individual
yeah,
runner.
runners. Yeah. So, so this is the default policy. So you either mention it as if not present or always. As the name suggests, if you write always, it will
Mm-hmm.
always download the image in your local Linux machine. And once it will download, and then it will execute the image. Okay. And
Okay.
uh, yeah, so that's pretty much it for the Kubernetes and Docker stuff. So till now we are clear, right? You are clear. I mean, till at least till this slide, how
Uh, y- yes.
like
Some. Yeah.
I mean, we will
Yeah,
get
but I mean, clear in the sense I still, I mean, what to,
like at least you understand
yeah, I
like
mean, what to say is I want to, go through YAML file.
yeah.
Yes, yes, I want to go through
So
the YAML file again and
yeah, at least you know like
each
what is a
one
Docker
again.
image and what is a container registry, right? So basically, we push our Docker image into the container
Yes, yes,
registry,
yes.
and you understand what is a kubelet. It pulls the Docker
Okay.
image into from the container registry
Yes.
which we have built. And so just keep in mind these things.
Okay.
So this is the YAML file we discussed earlier.
Okay.
And now this is the workflow.
Okay.
I mean, workflow means it's not like
Mm-hmm.
uh, this is like a typical workflow which is handy to understand when we do our labs. If you have
Uh-huh.
this picture in your mind, so uh, it it's helpful to what you are doing, what commands you are typing into the kubectl commands whenever we are typing. So
Mm-hmm.
this workflow is will help to understand. So first and foremost, as a developer,
Okay.
you build your application in C Sharp, Java, Python, whatever. Okay, and
Okay.
then you build a Docker image
Okay.
by using this command called Docker build command. Okay, so on your PC, on your
Mm-hmm.
local PC, and then it can be Windows.
Mm-hmm.
It can be Windows machine. You no need to have any Linux machine. It can be Windows machine as well. But once you have your Docker build command is done, and you push your image to the basically with Docker push command, you you push your as the name
Okay.
suggests, you are pushing your image to the Docker hub, or we discussed before like
Okay.
GCR, ACR,
Mm-hmm.
ACR, whatever. So for example's sake, we are using Docker hub here. Okay, so basically you
Mm-hmm.
you do a Docker build, and then you do a Docker push, and then you share with your team members. Okay, that okay, my
Mm-hmm.
Docker image is done.
Okay.
Docker
Okay.
image is pushed to the registry. Now, the next step would
Okay.
be to write a YAML file, which we wrote here, which you see here. So basically, this is the Docker file, Docker image we are pushing, with Docker container, which we are referencing here, right? So,
Mm-hmm.
the flow is like this. You build your application, you build your Docker image. Uh, of course, if the image is already built, then you don't have to build it again. That's very obvious. But
Okay.
if there
Okay.
is no image built,
Okay.
if it is a fresh application, then you have to
Uh-huh.
build a image from scratch. So so basically
Okay.
so the first part is application development, then Docker, and then
Excuse
Docker build, then Docker push, and then you
me.
write
Okay.
a YAML file. YAML
Okay.
file to pull so basically
Okay.
you're referring this Docker image into the YAML file,
Excuse me.
and yeah, and then
Mm-hmm.
um, you are pulling
Mm-hmm.
this image. Of course, using kubectl, this picture says, we had to in the AWS machine or in Azure cloud, we had to spin up a pod using kubectl command. And what
Okay.
kubectl does is basically it
Okay.
sends this YAML file, what we have developed here, here in this
Uh-huh.
example, it sends this
Okay.
YAML file to the AWS API server, which is actually running in the cluster. Basically you go to
Okay.
AWS cloud, you create a cluster, and then what kubectl will do
Uh-huh.
command, it will simply send this YAML file to
Mm-hmm.
the cluster, basically to the
Okay.
AWS API server, and then you're
Okay.
done because your job was still here. This is our job, like to write, you remember we talked about last sessions, we talked about replicas, like how many replicas you need. For example, nginx, you need three replicas to be up and running. So you have to mention here replicas, how many replicas, not mentioned here because this is a very simple
Mhm.
straightforward example. But when we go into more complex examples of YAML
Okay.
files, then we mention
Okay.
replicas, like how many replicas we need of this container,
Okay.
and then to so basically
Okay.
to push this YAML file to the AWS cloud or to the Azure cloud or GCP cloud, uh, uh,
Mm-hmm.
we have to use kubectl commands, and uh, we, before that, before
Okay.
sending the YAML file to the AWS cloud, we need to spin up a pod,
Mhm.
at least one pod. So um, um, so we will see later, like what is a pod, what is a namespace, what is like persistent volumes. So
Mhm.
we will see all those later. But just as of now, just theoretically,
Uh-huh.
just remember these, like these workflow. Just keep in your mind that I mean, from interview perspective also,
Okay.
it's good. Like you can just say like you build an image, you build your application, you build a Docker image on your PC, you put it to the Docker Hub, or
Mhm.
don't say don't need to say Docker Hub. You can say like ECR or ACR, depends on what you're comfortable. Or and then
Yeah.
yeah, so this is a flow, like and then once you have your
Depending upon.
yeah, once you have your image, you mentioned it into your this in the container path, in the name, like you mentioned the container name here, and then once you're done with it, then basically
Mhm.
you're pushing it to the AWS cluster. Um, yeah,
Okay.
AWS cluster. So this is like a total view, like Kubernetes and Docker, what we discussed right now. So basically, you're pushing the Docker image to the
Okay.
Docker Hub or to Amazon EC2 ECR, and then from there, after that,
Other
you
to
yeah,
hub.
you refer your Docker image here in this pod YAML file, and then yeah, you have written this command like
Mhm.
kubectl apply minus f pod.yaml file. So this is a YAML file, and when you write this command, automatically this
Yeah.
file will be sent to AWS cloud API, AWS API server on the cluster
EC2.
on the EC2, yeah, on the EC2. And then so basically you have to spin before
Mhm.
that, before sending writing this command kubectl apply minus f, you have to make sure that you have a cluster, Kubernetes cluster in the AWS. Kubernetes, we discussed it before in our last sessions, like each
Okay.
Kubernetes cluster will have a one node, one master node, and one worker node, like node processes, right? So we need at least, like here, one master node and three
Mhm.
nodes. Three worker nodes are here. Okay. So when you type this command kubectl apply minus f,
I mean, not necessarily.
say again,
Okay. Yeah. Yeah, go ahead.
say again. You're saying something?
No, no, no. You go ahead. You go ahead.
Yeah, yeah.
No, you said one master node and three worker node. It can be
At
more, right?
eh,
Worker nodes can be more,
Worker nodes can be more,
but there should be
but
one master, right?
minimum has to be one. Like minimum master has to be one, and
Yeah.
you can have like both master and worker nodes. No, you cannot have both master and worker. You need at least have one master and one worker node actually. So that's the requirement.
No,
That's
yeah. I mean,
yeah,
if a master is a major node, and then worker nodes, you can have a number of
yeah,
worker
n
nodes.
number of worker nodes. Yeah, you can have n number of worker nodes. Yeah, yeah,
Not a.
and
Okay.
uh,
Okay.
yeah. And worker nodes, it can scale up or scale down, both. Like all depends on what you written in your YAML file. If you if you make sure that if you want that whenever there is a high traffic and you want more nodes to be spin up, then you just mention the replicas, like the number of replicas you want. So Kubernetes will
Mhm.
automatically spin up those many amount of replicas. Uh, and if it feels like okay, this one node is not sufficient, it will automatically spin up another node. So we don't have to worry about that. I mean, Kubernetes will take care of all those parts. And so
Okay. Okay.
so this YAML file, you push it to the cluster, and then once you push it to the cluster, basically kubelet will pull the image from and run the container. So basically, in your node machines, which are here, kubelet will pull the image which you have built here,
Mhm.
and it will basically run your application on these worker nodes. Okay, and
Okay.
and then
Okay.
our job is done actually. So yeah,
Okay.
so and yeah,
Okay.
I think this with this we come to an end about this Kubernetes and Docker workflow. If you have any questions, We'll surely we can talk.
Yeah, I might need to go through the YAML file
Yeah,
again
yeah,
and
yeah.
try to um,
Yes,
understand that a bit more.
sure, man. That I mean that has to be done. Like else we'll forget. So